Welcome. In this video, I'm going to give a brief overview of the steps involved in analyzing a nominal variable. I will show an example of the end result as well, but I have separate videos for each specific step in there. So this is just going to be a brief overview. So in order to analyze a nominal variable with 3 or more categories, I would usually first get an impression of the sample data by creating a table with frequencies and percentages. Then draw a visualization of that by using a bar chart, although a pie chart, a dot plot, and a Cleveland dot plot might also be suitable. As measure of central tendency, you can have a look at the mode, although it's not that frequently reported directly, and a measure of dispersion, how much variation there is, and the most common one is probably the variation ratio, although there are a lot more of these. Usually I don't see mode and variation ratio explicitly being mentioned, but sometimes indirectly they are. More on those, of course, in their own separate videos. Once I got an impression of the data, I might want to know if there's any significant differences between how often different categories were chosen. For that, I can perform an omnibus test. In this case, I would usually use the Pearson chi-square test of goodness of fit. That's different than the Pearson chi-square test of independence, so be careful, there are two different versions of a Pearson chi-square test. Alternatively, a G-test is sometimes used, also known as a likelihood ratio test. That will tell me if any of the categories are significantly different. If so, I then want to know which ones. For that, I can use a post hoc test, and usually the pairwise binomial test can then actually work. That will be an exact test. Or I could use a pairwise z-test or z-test for proportions. Then I would like to know the effect size, because APA always likes to use effect sizes or likes you to add them in. So for the omnibus test, we can use Kramer's V for goodness of fit. Again, similar as with Pearson chi-square test, also with Kramer's V, there are two different ones, one for the goodness of fit, one for the test of independence. Alternatively, you can use Cohen's W or Johnson's Berry-Mika E, but that one is slightly less familiar to others, so that's a downside sometimes of something new. That many people are not familiar with it, and perhaps you want to show them something that they are familiar with. Anyways, for the post hoc test, you can have a look at the how to analyze a binary variable, and there we saw relative risk and Cohen's H. Of course, then we need to report all the findings. So the main example I'll be using is from different marital status. I think this is just some random data, or actually it's from a general social survey from 2012 or so. But here's the frequency table of the marital status. It's clearly a nominal variable with more than 2 categories. And so marital status, and these were the options people could choose from. And the frequency and the percent and valid percent are the ones that I'm actually only interested in. Cumulative percent here doesn't really do anything. So this gives me a first quick impression. I noticed that most people are married, and by far the least are separated. There are a few people who didn't answer the question, and that's about it. So like I said, I will not use this often in my report. I would make a visualization out of this and then write up the rest of the report. So here's an example of how I might report all of this. It starts off on top with a quick introduction as into why am I even looking into this. Then that's followed by a visualization of the sample results, in this case a nice bar chart. And I always introduce the diagram as seen in the previous paragraph, then show the visualization, and then talk about that visualization. So introduce a diagram, show the diagram, and then talk about the diagram. In this case, there's not that much to mention. It's just that almost 50% said that they were actually married and only a few were separated, similar as I concluded from the frequency table. Then I need to test if any of those are actually significantly different. That's where that chi-square test of goodness of fit comes in. You'll notice a bunch of numbers in here in the separate video on the chi-square test of goodness of fit. I'll explain more on these, but usually the software that you're using can easily find these numbers and it's just the same format. So in this case, this was below 0.05, which usually is then considered significant. I also have the effect size here for the omnibus test, which was Kramer's V, which according to some conventions can be considered to be relatively strong. Then for looking at which groups were really different, that's usually a bit hard to write down because especially if you have many groups, it's sometimes a little bit you don't want to list all possible combinations. So like this one was significant, this one wasn't. Sometimes that is done by using a table showing which ones were and which ones weren't significant. But sometimes you can just summarize the result like where all of them were significantly different with this one. And I've done something similar here. Last but not least, you might want to draw a somewhat more plain English conclusion there for people who don't have had a statistics course. And of course, be aware that a test only tests if things are significantly different from each other, not if one is actually causing the other. So always be careful with that. So this is just an example that I will be working towards. And for each of these stages, I have separate videos where I explain slightly more on what they mean, and also have videos on how you can actually get these results. So on peterstatistics.com, you can actually find slightly more information already. If you then go for one variable, and this was about a nominal variable, then you should see on the left-hand side a nice menu with those basic steps. If you click on each of them or one of them, you will see the information showing up in the main area. In those main areas, there's usually a click here to see how. In orange, if you then click on that sentence, it will show a submenu with various programs, with SPSS, with R, with Excel, with Python. Those are the main ones, or manually. Perhaps in the future I add some more. And unfortunately, sometimes something is not possible to calculate with that specific program. But then usually one of the others is fairly straightforward, or I sometimes add an online calculator for it. You can then click on it, like here I've clicked on with Excel, and then there's embedded video of YouTube where I explain how you can get that result with that particular program. You can then also open it on YouTube after you hit the play button if you want to see it on a slightly larger window or on a separate screen. All right. Well, that's the brief overview on how to approach analyzing, or how I would approach analyzing a nominal variable. Hope this was clear, and good luck with the steps. Hope it all speaks for itself. Thank you for watching.